Welcome to Eureka Math. I'm Mr. Schenkel. This is 8th grade, Module 4, Lesson 7. Let's get started. Okay, our job is to solve each of the following equations for x. And what we're going to do today is, before we go ahead and solve, first we're going to decide if there is a unique solution, or if there's infinitely many solutions, or if there's no solution at all. And we can do that by just looking at the equation before we start. So this side, this equation has two sides with expressions that are simplified as much as possible. We've combined like terms, and there's nothing else we can do. And what I notice is the coefficients. So these coefficients in front of the variables x are different. And if they're different, that's a clue to me, tips me off that we are going to have a unique solution, because if I were to move the variables, subtract 5x from both sides, then I'm going to get some x's left over here on the left side. So 7x minus 5x is 2x minus 3 is equal to 5. And I know that I can isolate x and it will tell me what it's equal to. So this has a unique solution. So I'm just going to make myself a note that this is a unique. Wow, my pen is just slacking. There is a unique solution. So I'm going to go ahead and continue to solve this and isolate the x so we can find out what that unique solution is. So add 3, balance the equation. We get 2x is equal to 8. And then if I multiply by reciprocal, I will get x all by itself. Balance the equation again. The 2's go away. I get x equals 8 divided by 2 is 4. So that is the unique solution. X equals 4. It's the only value that x can be that will make this statement true. Okay, so that's one possibility. Let's look at another. If I look at the coefficients this time, I see a 7 in front of the x, and I see another 7 in front of the x. If this happens, I know for sure that the x's are going to go away. In fact, if I tried to do that, subtract 7x from both sides, they're both going to cancel. 7x minus 7x, that's gone. I get negative 3. Come on. Is equal to, the 7x goes away here, 5. So negative 3 equals 5. So I know that the x's are gone. That means I'm not going to have a unique solution. And then all I have to do is check the constants. And I can see a negative 3 and a positive 5. Those do not equal each other. So I know this is going to be a no solution equation. There is no value of x that will make both sides true, both sides equal to each other, or the statement true. So check the coefficient. If the coefficients are the same, then check the constants. If the constants are different, then it's a no solution. All right? The other possibility is this. If I rearrange this, 7x minus 3 is equal to, if I put the 7x first and then the negative 3, I can see 7x minus 3 equals 7x minus 3, and everything's going to go away. Or if I check the coefficient is a 7, the coefficient is a 7, I know the x's are going to eliminate each other. And then I check the constants, a negative 3 and a negative 3. Since those are the same constant, I know that this is going to be an infinitely many solution. Okay, infinitely many solutions. That means any value of x is going to make the statement true. So while we're working on these equations today, that's the first thing I want to look at, because I don't want to do all the work if I can quickly see that it's a no solution, or if it's an infinitely many solutions. I want to know that as soon as possible so I don't have to do all the work for no reason. So that's what we're going to practice today. We're going to just decide whether we need to solve it or not. So In order to do that, I need to simplify sometimes. So in this case, you can see I have 11x and I have a negative 2x. I can put those together and get 9x plus 15 is equal to, in this case, on the right-hand side, I have a 9x plus 15. So those are exactly the same. And if I look at the coefficients, they're both 9s. So I know the x's are going to go away. Now I look at my constants. They're exactly the same. 15 does equal 15 every time. So this is an infinitely many solutions type of problem. Infinitely many. So I don't have to solve it because x can be anything. In fact, I really don't even have to look at the coefficients and the constants separately. I can just say, well, the left side's exactly the same as the right side, infinitely many. Number 5. Distributive property, 3 times x, that's 3x. 3 times a negative 14 is a negative 42 plus 1. And that's equal to a negative 4x plus 5. Okay, well, I want to look at my coefficients. That's a 3x. That's a negative 4x. They're different. So I am going to get a unique solution here. So I need to continue and solve. So I'm going to add 4x to both sides. That's going to give me 7x. And then a negative 42 and a positive 1 is a negative 41. Put those constants together. Is equal to 5. And then we can continue isolating the variable. Add 41. Balance the equation. 7x is equal to 46. And then I like to multiply by reciprocal just so when we get a fractional coefficient, I don't have to do anything differently. The 7s go away. I get x equals 46 sevenths. Good answer. Leave it right there. You don't need to change that to a mixed number. Improper fraction is awesome. So one solution, 46 sevenths is it. Number 6. Let's see. I've got a negative 3x. I have a negative 7x. That's a negative 10x plus 32 is equal to distributive property. This is a negative 10x. Okay, so I see it's either going to be infinitely many or no solution because the x's are going to go away. Negative 2 times 10. Negative 2 times 10 is a negative 20. So if my coefficients are the same, then I look at my constants. The constants are different. 32 does not equal negative 20, so this is no solution. No need to go any further. I already know there's no value of x that will make it true. Okay, number 7. Distributive property. Half of 8x is 4x. Half of 26 is 13. And that's the same, 4x plus 13. Same thing, infinitely many solutions. Infinitely many. There, that's quicker, right? All right, that's 7. No need to go any further. There, I could choose any value of x and it'll be true. Number 8. Write 2 equations that have no solutions. Well, all we need to do is make sure we have the same coefficient of x on both sides. Let's use a 2 this time. So 2x equals 2x. And then I need the constants to be different. So I'm going to go with a plus 1 and a minus 1. How about that? So when I get rid of the 2x, I'll have 1 equals negative 1. That's not true, so it's a no solution. So there's 1. How about we do this? A negative 5/3 x plus 7 is equal to negative 5/3 x minus 1/2. Okay, this time if I get rid of the x's, they're going to go away. I'm going to get 7 is equal to negative 1/2. That's not true, no solution. So for no solutions, coefficient of x is the same, but the constants are different. Number 9, two equations that have one unique solution each. So this just means we can make it simple. We can just say 3x plus 1 equals, I don't know, 7. That's going to have one solution because I can isolate the x. It's going to tell me what it's equal to. If I put x's on both sides, I just need to make sure that my number of x's is different. So a negative 4x on one side and let's say a 7x on the other side. That would be a good one because when I move the x's to one side, I'm going to have x's still remaining in my equation. I'll be able to isolate it, and there will be one unique solution. Okay, there's a couple of those. And then for number 10, write two equations that have infinitely many solutions. This is where both sides are the same. So if I said, let's go with 8x plus 1 is equal to 8x plus 1. That works because I'm going to get the x's will eliminate. I'm going to get 1 equals 1. That's true no matter what x is. So that's an infinitely many solutions. And that's all we do. Coefficients have to be the same. And so do the constants. So negative 1/2. 3x minus 1/2 is equal to, let me flip this around, negative 1/2 plus 3x. Those are the same thing, a positive 3x on both sides, a negative 1/2 on both sides. I'm going to get negative 1/2 equals negative 1/2. That's always true, so there's infinitely many solutions. It will not matter the value of x. It will always be true. All right, that is lesson 7. Hope that helps. See you again next time.